Hello people, Enchanted Goose here with another build video. I've done in the past a ZVS how-to video, however that was without a board attached, and I consider circuits that are made in this fashion a bit too, let's say, not to my standards, let's say. Yeah, so I have our components here for the self-resonant ZVS version. This is the schematic, and as you can see, you have VCC from here, and this is the resistor divider, 220 ohm resistors feed directly into the base, into the gate of each MOSFET. As in the other build, we have 15 volt Zener diodes across, 10 kilo ohm resistors to protect the Zener diodes across the source and gate terminals. And what we also have is, let me find it, one UF 1508. It's a 3 amp ultra fast diode, but any ultra fast diode will work, not a Schottky diode. Do not use Schottky diodes for this, only ultra fast diodes. So diode from the gate of this MOSFET to the emitter, the drain of this MOSFET, and then you use another ultra fast diode that is from the gate of this MOSFET to the drain of this MOSFET. Here the two inductors, as you can see, both feed they both feed into the drains of the MOSFET, and over here we have a capacitor, and it's a polypropylene capacitor rated at 1600 volts, 100 nanofarads, and over here you can connect anything you want. It could be in an induction heater if it's an air core, or it could be a high voltage transformer if you add transformer. So the transistors I'm gonna be using, the MOSFETs I'm gonna be using, are the STP80 NF10, which are 80 amp MOSFETs and 100 volts. I have them already mounted them with silicone padding and and a screw which is also insulated with a plastic insulator. So those are our MOSFETs. We have our capacitor over here. We will need two clamps. We will need again two Zener diodes, two resistors to connect to the base, to the gate of the MOSFETs, two ultra-fast diodes, and two 10 kilo ohm resistors, and two toroids. Any toroids will do. If it's in the range of 40 to 200 microhenry. Anything in that range will work. Now the capacitor over here should be noted, must be a good quality capacitor, polypropylene or MKP. I'm using an MKP capacitor, as you can see. So let's start the build. I've already punched holes so my transistors can get in, because they have that thing in the heatsink. So I'll go and add those and we will proceed. And the MOSFETs are on the board. From the down side it looks something like that. These are the legs of each MOSFET. Now let's solder them on the board. As you can see, I've, like the last build, bent the leads, the gate and source of each MOSFET down, and the drain terminals to the front, so it will be easier for me to add the components. So let's start by adding the Zener diodes and the 10 kilo ohm resistance. So the Zeners are added. Now let me add the 10 kilo ohm resistors. So we've added the resistors, and now it's time for some soldering down here. All these pins must be connected to, well, firstly they have to be soldered and cut, and then connected to each gate and drain terminal, gate and source terminal, and gate and source terminal respectively. So let me do this and you'll see how the final product will look like. So we need to join those pins with the gate, and we need to join those pins with the gate, those pins with the gate, and those pins with the source. Did I say gate over here? No, with the source. This goes to the source, those go to the base, the gate, and so on. Let me fix it and I'll show you. So guys, this is what it should look like. We have connected both the Zener diodes and the 10 kilo resistors across the gate and source terminals of both MOSFETs. And now we will proceed to add the diodes. So we will be using these ultra fast diodes as with the previous build. I checked the recovery time and it's actually 15 nanoseconds, which is probably less than the switch time of the MOSFETs. So yeah, I've also punched some holes as their leads are a bit thicker. Let me add them. I'll show you which direction we add the diodes because that is really important. So the diodes were added, and pay close to where this white stripe is on the diode. This indicates the negative terminal, and how are they connected? They are connected the first diode, this one, goes from the gate of this MOSFET, this one, to the drain, the middle pin of this MOSFET, and the diode that's in front of it, it's exactly the reverse. Goes from the gate of this MOSFET and feeds in to the drain of this MOSFET. Now let me solder everything up and we will continue. As you can see, everything is soldered up nicely. Now let's add these two toroids over here. It was quite a bit to wire this thick wire over them, but that was the only wire, the thick gauge wire I had, so I was like, well, we'll go with this. So let me punch some more holes into the board so we can add our inductors, and we will proceed from there. So as you can see, after me literally drilling the fucking board, I managed to get those inductors in. That's how it looks from the back side. So let me show you now how we will connect those inductors in a second. So the wires in the front will be joined together, as this will become our resistor divider, in which we will add the gate resistances. Now, as I said from the schematic, each leg of the inductor goes to the drain of each MOSFET. Now on this side, since the diode is directly connected to the emitter, we have no problem. So we just solder it over there. Now on this side, because the diode goes on the gate, we need to insulate it and only solder this side that goes to the drain of the MOSFET. So find a way to insulate your lead in that point. I used a piece of silicone wire. I took the wire from inside and inserted it like a sleeve on the wire thingy. So now let's connect everything with solder, and I'll be right back to add the gate resistances. So as you can see, we've added the gate resistances. Don't worry, it's not like we're running out of space. So its resistance is over here and over here, and the resistance that feeds from this wire feeds directly to the base, to the gate of this MOSFET, and this resistance is over here and feeds to the gate of this MOSFET. So now we will join this with solder and then join it with the two soldered pins that are coming from the power inductors. So let's do that. So as you can see, you have soldered both of the resistors onto the resistor divider and to the both of the wires coming from the inductors. And now it's time to add our capacitor. So the capacitor must be connected to both of the drains of these MOSFETs. So let me add it, and I'll go into more detail in a while. So you can see these are the capacitor's legs. We've added the capacitor, and now it's time to solder it to both the drains of the MOSFETs. Let's do that. So as you can see, both of the drains are connected to the capacitor. Now the circuit is almost done. We need to connect both of the sources, this one and this one. I'll use this piece of wire to do this, and I'll be right back. So I've spared you the time and added both the input and output clamps. This is the input clamp, this one. This one. And essentially what we will be connecting over there is a wire from the resistor divider and a wire from the joined sources of the MOSFET. Let me do that and I'll be right back. So the positive and negative are connected to the clamp. From this side I just added a bit of solder, there was no point for me to add a wire. This side I just took a jumper wire and connected it to this side of the clamp. Now let's do the output and we are done. So guys, this is the output. I connected with a bit of solder the left side of the clamp, and because I'm not a true masochist, I just put a jumper wire from this side to this side instead of solder, because yeah, I didn't feel like soldering this whole thing and it would have no point anyway. So yeah, that is the device, and now let's see how it performs. As you can see, we are at 6 volts, about 240 milliamps. The circuit is self-resonating. Oopsie. Let me take it back. It fell. So, as you can see, I placed the ground to the drain of one MOSFET. I placed the probe to the drain of the other MOSFET, and over here we have, when we have our waveform, it's at 63.2 kilohertz, and in comparison to the other ZVS circuit, which does not self-oscillate, this one, besides that, has the ability to, which is also true for the one choke ZVS, to actually resonate with the transformer you add to the output. So let's see what we can add and how it performs. Let's try a flyback transformer. So guys, I've connected it to a CRT flyback. I took some silicon wire and made, I don't know, 8 loops for the primary, and I've set a Jacob's ladder for effect, I guess. So let's see what happens. Let me turn off the power slowly. This is the ZVS driver again. This is the CRT flyback, and this is the Jacob's ladder. As you can see, it easily powers the transformer and forms a beautiful Jacob's ladder. Now it draws about 3 amps at 31 volts DC. My MOSFETs are not hot by any means. This can be running for hours, for all I know. The system is really stable. I would really be worried for the capacitor to fail rather than the MOSFETs. They're 80 amps drain MOSFETs, they're monsters. So let's try induction heating now. After the high voltage experiment, our ZVS oscillator is working perfectly, at least for high voltage arcs and stuff. Now let's try induction heating. I have my favorite knife here that I use for induction heating purposes. So let's see. You know, I'd say it works pretty well as an induction heater too. So yeah, it's a circuit that can have many uses, as you can see, from producing high voltage to induction heater, as any ZVS drive is capable of course. And yeah, that's about it, guys. It's not anything special. It's a very simple circuit, I must add. I really like that is a self-resonant circuit. That means it can oscillate on its own with no load added. Let me show you one look at the front and from the back side. And well, that was for today, guys. Remember that we started with a couple of components and now we have a working device that can do lots of things. Now, why someone would do this? Well, for fun or for something else. This channel is not about doing precise science. It's about engaging with science and making people interested in it. My goal is to make people get interested in science, not to showcase how you make a ZVS circuit. Anyway, so that being said, thank you for watching. I know it was a long video. I was babbling a lot. But yeah, thanks for watching. Share, like, subscribe if you haven't already. I have lots of different videos coming up. And yeah, that's about it. Enchanted Goose signing off. Goodbye and thank you.